Okay, this is lesson P.3. We're going to go through a few of the examples here and then get going. This is all about linear equations and linear inequalities. These should be relatively straightforward. So this is example 2 and how to solve a linear equation with several parts in it. So this is like, 9th or 10th grade level. It's probably 9th. It's probably a challenging 9th grade level. So we're going to start by distributing on both sides. So that means I'm multiplying 2 times 2x is 4x, and 2 times -3 is -6, plus 3 times x is 3x, plus 3 equals 5x plus 2. I'm going to start gathering like terms. I'm going to move all of the numbers to the right, and all of the x's to the left. That'll give me a positive x. So here on the left, I've got 4x plus 3x minus 5x. That's 7x minus 5x is 2x. On the left, I've got 2 plus 6 is 8, minus 3 is 5. I will divide by 2 and get x equals 5/2. I have solved that equation. So next one we're going to solve is example 3. We're going to do one with fractions. Just using a page. We've got 5y minus 2 over 8 equals 2 plus y over 4. And first thing I'm going to do is I'm going to multiply everything by the common denominator here of 8 and 4. I'm going to multiply everything on both sides by 8. This is called clearing denominators. So that gives me the left side, 5y minus 2 over 8 times 8 just gets rid of the denominator. The right side, 2 times 8 is 16. Y over 4 times 8 is plus 2y, because 8 over 4 is 2. Now I will go ahead and gather terms to the same side. I'll subtract 2y from both sides and add 2, giving me 3y on the left and 18 on the right. I'll go ahead and divide by 3 and get y equals 6. Because I didn't have anything in the denominator, I probably technically should check. 5 times 6 is 30, minus 2 is 28 over 8 equals 2 plus 6 over 4. 6 over 4 is eighths, is going to be 12 over 8. And 16, that is 28 over 8. That's correct. Example 4 involves an inequality. It's going to look very similar to solving an equation. So again, I'll start by distributing. 3x minus 3 plus 2 is less than or equal to 5x plus 6. I'm going to move my x to the right this time because that'll keep it positive. Actually, no, I'm going to do it to the left so I can show something else. So let's do minus 5x. -3 plus 2 is -1, so I'm going to add 1 to both sides. So I combined like terms and then I moved it. So this is going to cancel out with that. All 3 of those are that 1. I get negative 2x is less than or equal to 7. I will divide by negative 2. When I divide by a negative or multiply by a negative, I must switch the direction of the inequality. And this is a negative 7/2. So I turned my inequality around. If I'm graphing this on a number line, I always want the x on the left because then this faces as the direction that my arrow goes. 7/2 is 3.5. This is a closed circle being an or equal to. And this arrowhead is the same direction as my inequality. Okay. Solving ones involving a fraction. This is going to be very similar to what I did for the other one involving a fraction. Where I'm going to multiply by my least common denominator of 2, 3, and 4. That's 12. So I'm multiplying everything by 12. 12 times x over 3 is 4x. 12/3 reduces to 4. 12 times 1/2 is 6. 12 times x over 4 is 3x. And 12 times 1/3 is plus 4. I'm going to move, this time I'll move the x to the left and the numbers to the right, and I get x. My solution is x is greater than negative 2. Again, on the number line, 0, negative 2, open circle. X is on the left, which means my arrowhead is there. I know I've taught you before, if x is not on the left, flip it around so x is on the left. Make sure the inequality faces the same direction. And our final example is solving a double inequality. There is a way that you can do this. It's going to be a little shorter and you work things. Everything has to apply to all 3 parts. What I'm going to do is I'm going to split this up. I think this is the easiest way to not make a mistake, is to solve the 2 inequalities together. This is an and statement, so it has to be overlapping. So solving both of these, I'm going to start by multiplying both sides by 3. That gives me negative 9 is less than 2x plus 5. I'll subtract 5. Negative 14 is less than 2x. I'll divide by 2 and get negative 7 is less than x. Again, I'll multiply both sides on this one by 3, get 2x plus 5 is less than or equal to 15. I will subtract 5, and I will get 2x is less than or equal to 10. X is less than or equal to 5. So if I'm graphing these, I'm going to do this. So I turned mine around, put the x on the left. So I've got an open circle, and this goes this way. My 5 is a closed circle going this way. My solution is the area where they overlap. So from negative 7 to 5, if I want to write it again as a compound inequality, so 2 inequalities in one, I can take this, take the two x's and squish them together to make one in the middle. So this functionally means x goes from -7 to 5. If we want to talk interval notation, which will come up later in this, we're looking at that. Okay, that is section P.3.